Hello dear students, today I will discuss about maximum value and minimum value of function of two variables, maybe function of three variables, that is the process for finding maximum and minimum values of function of multivariables. Okay, so in case of as a single variable function, we know we are trying to find the value of extreme value by using first derivative equals to 0 and then find second derivative at that point. First derivative is equals to 0, then we can find a stationary point, and at that point whether the second derivative is negative, then maximum, positive, the minimum. Okay, so this was the method for finding maximum minimum value of function of single variable. Function of single variable means in graphically we know the function of graph of function of single variable as a curve in a two-dimensional plane. But here function of two variables, suppose we are having function of two variables, then we know that function of two variables means that is denoted by fxy. Function of two variables, this is denoted by z equal to fxy. Clear? So here z equals to fxy, that is function of two variable is this, its maximum value. Its graphical representation is surface in a space. Okay, because xy as a point of domain of this function of two variable and z is the value is plane in lower plane, suppose xy plane, and corresponding to a point the value of z is on the surface. So maximum point on the surface, just we have to find that maximum point, or surface may be as a ball condition, as a dome condition. That as a dome condition means tangent plane parallel to the base plane, that is xy plane, then the touching point to the tangent plane and surface is maximum point. Similarly as a ball, condition of the surface, tangent plane at the bottom of the ball is parallel to the xy plane, then that point is minimum point. So z gives the value of the function. So we are just denoting like this. This is x-axis, this is y-axis, this is z-axis, that is z equals to what? fxy. That is our point in xy plane. And surface, the value of z is in this direction, that is function fxy, its maximum value and minimum value we will try to find. Suppose in xy plane there is a point AB. In xy plane there is a point in AB in the domain of this function. Then corresponding to this value of the function, that is value of z on the surface, that will be maximum if surface is just like this dome. Just in the first diagram you can see that a dome is there and tangent plane on the top, and touching point is corresponding to AB, suppose. Then that is the top, at the top maximum. This value will be maximum if around this, on the surface, around this surface descends. That is, if its neighborhood, there exists a neighborhood of this point AB in the plane, that is in plane, this plane. Neighborhood means just suppose circular neighborhood. Then the value of A, neighboring point we can suppose A plus H and B plus K. That is something plus H and K may be negative or positive both. So this is neighboring point of A, and on the value of H and K, the dimension of neighborhood will depend. If for all values of H and K corresponding, we can get other points. If all that points on the surface corresponding to this point, the value of the Z is less than the value of Z at this point, then the value of Z, that is value of fxy at this point, will be maximum, because in the surface, just like in the diagram drawn, at the top point, that is corresponding to this point AB, will be the top, and that will be the maximum if corresponding to comparing to the values near about this point on the surface is greater than, always that point is greater than near about this on the surface. That is corresponding to this and corresponding to this value. That means F A plus H B plus K minus FAB, just we can write like this, minus FAB, that, or we can write like this for all H and K, for, you can write for all small values of H and K may be positive or negative. That is, Hk may be positive or negative, and small values of Hk for all, if this, that is, point in the neighborhood of this point is this, and value of the function at this point is less than the value of the function at AB. If this, for all H and K, small values, positive may be negative also, okay, then we say that the value of the function is maximum at AB. Then FAB is maximum value. AB means at A, fxy, that is fxy is maximum at AB if this condition is satisfied. Here all small values h and k, maybe this. It can be also written as like this, taking left hand side, minus of this minus this is less than 0. Less than 0. Clear? If this minus this is less than 0, that is this sign of this is negative, then maximum. Always negative. In this neighborhood. Neighborhood is decided by this h and k. H are small values and may be positive or negative. In this condition, maximum point is what? AB from the domain. This is at this point function having maximum value. Similarly, minimum value. What minimum value? Minimum value for this less than maximum. Minimum here will be greater than sign. That is, this is greater than this. That is, always this value of the function at this point will be less value. That is, if we take here less, just like this. Suppose this, then minimum value. Then minimum value. That is minimum value. Clear? Like this. Because here FAB from second, just second part, second diagram, you can see there is a surface like this ball, and bottom, at the bottom there are tangent plane. At the tangent plane is parallel to this xy plane, then tangent plane and touching point of ball, that will be the minimum point. And around this, the value on the surface are, that is the value of z, are greater than at that point. That is, this is greater than this for this neighborhood point. Okay? So, this condition can be also written as this is greater than this, then minimum, or we can write like this, this is greater than 0. That is, this is positive, this value is positive, this difference is positive for all h small h, hk may be positive or negative in this neighborhood. From the second diagram it is clear. Okay, corresponding to this, there are the value of z like this, dome for maximum and ball for minimum. Clear? Corresponding to this point, like this. Here, this is tangent. Okay, this is tangent. This is the minimum. And maximum. Maximum. Clear? Corresponding to this. Similarly, from second diagram, for minimum value, we can write how? This is tangent plane. Second diagram, it is clear that at this point, this is f and b. Minimum in the second diagram. Okay, so minimum. So always positive for this. That is, sign will be same in the neighborhood. That is, whether maximum or minimum, that will depend on the sign of this quantity. Okay, and there may be some point where, just in first diagram we see that around the point FAB in the dome, surface descends, and in the second diagram for the minimum point, surface ascends around this point. And there may be point in the surface in one direction, surface ascends, and another direction descends. So ascends and descends both. That means in that case we can say there no maximum will, no minimum will. That is in third diagram you can see. In third diagram, just like leather seat on the back of horse, just see the diagram. There is point, whereas there may be some point on the surface where around that point surface ascends in any direction, in any direction, and descends in another direction. So neither maximum nor minimum. That type of point is called saddle point in the third diagram. What? Saddle point. Saddle point in third diagram. Neither maximum nor minimum. Okay? Neither maximum or minimum in the third diagram. Okay. So here just our discussion gives that the sign of this is positive, then we say that minimum, that is, and sign of this is negative, then maximum. Okay, so we will try to formalize it. It can be formalized by using Taylor theorems of function of two variables. Taylor's theorem of function of two variables, just like as a function of single variable, Taylor's theorem. Here for the function of two variable, Taylor's theorem is, just we are writing for single variable function Taylor's theorem. Here for function of two variable, del f by, we can write also del z by del x also, Taylor theorem, function of two variable, this is for this Taylor theorem. Taylor's theorem. Taylor's theorem for function of two variable. Del f by del y plus 1 by 2 factorial h square del 2f by del x square 2hk del 2f by del x del y k square del 2f by del y square. This is Taylor's theorem of function of two variables. By using this theorem, just we can find sin f a plus h b plus k minus fab, just transferring on the left hand side this quantity, and right hand side 1 factorial 1, so h del f by del x plus k del f by del y. This is equation 1, this is equation 2. Here, as we take a small neighborhood, so h and k are very small, and its second degree and higher degree will be also very small. So we can neglect that term. So here h square, hk, k square, there are small, very small quantities. So we can neglect it. So neglecting higher powers of h and k, higher powers of h and k, we can write like this. Now our target is what? Its sign. We want to know that its sign should be same. Maybe negative, maybe positive. If negative, then maximum at this point. If positive, then minimum at this point. Then maximum value, minimum value. So our target is finding its sign. Clear? Its sign by using this theorem. Okay. Now, see, if this is negative for all h and k, for all h and k means its sign should be same for all small values of h and k, may be positive, may be negative. So, here we see that its value, we require its sign. Clear? Suppose h equals to 0, then its sign will depend on the sign of k. Clear? So there will be no maxima, no minima, because for maxima or minima its sign must remain same, because same sign, either positive or negative. Positive then minimum, negative then maximum. So if h equals to 0, then its sign will depend on k, then there will be no maxima, no minima. That means this should be equals to 0. Similarly, if k equals to 0, then its sign will depend on h. So there will be no maxima, no minima, because sign should be same. So del f by del x equals to 0. So this is the necessary condition for existing of maxima and minima. So necessary condition for maxima and minima, we must have what? This is equals to 0, this is equals to 0. Del f by del x equals to 0 and del f by del y equals to 0 at the point, desired point. So this should be equals to 0. The point in domain of the function where this and this are 0, for that point we are trying to find its sign. Its sign means either positive or negative. Sign should be same. So are the necessary condition. By solving these two, we can get point at which function may be maximum or minimum. Maximum minimum is extreme value of the function. Extreme value means maximum minimum value. Okay. And also here this sign of this quantity remains same. For that we are bounded this should be 0. So these are the stationary equation, or we can say this gives stationary points for the function, which gives stationary points, stationary points for function fx. These two equations can be solved and we can find some values of x and y as a pair, that is points, maybe 1, 2, 3, 4 points. They are called stationary points, which it gives a stationary point. Stationary points, at the stationary points we can get maximum value or minimum value. For that we require its sign, whether its sign is positive or negative. Okay, so for determining the sign we can use equation first. Here we see that this and this are the necessary condition. If these two conditions are satisfied, then the sign of this quantity will determine by this quantity, we can suppose, and have degree terms may be neglected. So from equation 1, if these two conditions satisfy, so from equation 1 we see that sign of f a plus h b plus k minus f a b, sign of this is equals to sign of, because these two quantities 0, so this is 0, this is transferred to here, so this is equals to, this is 0, second term, we can use this term, sign of 1 upon 2 factorial, and here we see that inner part we are also denoting this second degree order derivative by r, this is by s, this is by t. So we can write here h square r plus 2hk s plus k square t. Okay, sign of this. From here we can get condition. Sign of this is same as the sign of, it can be written as like this. It can be sign of, because 1 upon 2 factorial is also, we can suppose this 1 upon 2 positive, so sign of this. So this quantity can be adjusted by making perfect square. Here h r plus ks, h r plus ks, it can be written like this: 1 upon r h r plus ks square plus 1 by r k square rt minus s square, k square rt minus s square. Okay, now we can decide. This is our stationary equation for maximum minima. This should be satisfied. Okay, by using this here 0, so second from here just we are trying to find its sign. So sine of this quantity is equals to sine of this. Here this is positive. Now just writing in the terms of r s t. This is r, this is r, this is s, this is t. In this format just we are writing and then making perfect square like this. Here we see that this is positive, hk may be any value, positive, negative. So square quantity positive. K square, k may be positive, negative, also positive. Positive, positive. So in this case, for determining its sign, sign of this equal to sign of this, so we can write here if this is positive, suppose this is positive, then total will be positive and its sign will depend on r. So we make condition rt minus s square is greater than 0, and if r less than 0, then its sign will be negative, maximum. If r is positive, then minimum. So this is our condition establishment. Okay, that means if rt minus s square is greater than 0, this quantity is greater than 0, then if this and also r greater than 0, this is positive, this is r is positive, this is positive. Positive means minimum. Okay, so first write r is negative, then maximum, because r negative, positive, 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 or negative, and negative, sign is negative, maximum value, maximum. And if this is positive and r is greater than 0, this is positive and also this is positive, so r greater than 0, so then we get minimum. So this is our testing condition. Clear? Now, secondly, if this is less than 0, if this is less than 0, in that case, if this is less than 0, then this sign of this quantity is positive, this is will be negative value, and here h and k, how much value is this? That h and k, positive or negative, so how much value is this and how much value is this? If this is greater than this, then positive. If this is less than this, then negative. That means sign will depend on the value of h and k. So there will be no maximum, no minimum. Sign of this quantity will depend on the sign of value of h and k, or the positive, negative. So there will be no maximum, no minimum if this is less than 0. So if this is less than 0, then no maximum and no minimum. No maxima, no minima. There is no maxima and minima. If less than 0. And if this is equals to 0, if this is equals to 0, and if this is equals to 0, if this is equals to 0, then if this is equals to 0, then we get 1 by r into this. And this may be 0. Will depend on the value of h and k. If this is 0, then sign cannot be decided. That is, our case is doubtful. Then the case is doubtful. Case is doubtful. Okay? So further investigation we require. Further investigation we require means just in this case try to discussion for maximum minima by the given condition in the problem, physical condition in the problem, and in any other way we can decide for maximum minima, whether at that point maximum or minimum. Okay, points for stationary points, which at that point whether maximum or minimum. If this is 0, then we can use other method. So then the case is doubtful, and further investigation is required. Okay. Further investigation is required. That means if this is 0, then this case is doubtful. And so another method we can use for decision, getting decision whether at that point function is maximum or minimum. Okay, this. So remember this condition. What will be our working rule? Just see in this sheet the working rule. Working rule for finding maximum and minimum value of function of two variables. Okay. Working rule. See here. What is working rule? First of all, just find, write the given function fxy is given, just find this value, del f by del x and del f by del y equals to 0, and as a simultaneous equation just solve it, and you can get point which gives a stationary points. As how? Points may be 1 points, 2 points, 3 points as order pair, maybe points like this, a, b, 1 point, another point, c, d, and also maybe 1 point, 2 point, 3 point. For each point we'll test this. Just find r, s, t and use this r, s, t and just test, find the value of rt minus s square. If rt minus s square is greater than 0, r is less than 0, maxima. If this is greater than 0, this is greater than 0, minima. If this is less than 0, no maxima, minima. No max or minima. If this is equals to 0, case is doubtful. So using this working rule we can solve for maximum minimum. We can find the maximum minimum value by using this condition. That means first of all we will find del f by del x, del f by del y, and then equate it 0 and solve this two equations simultaneously. We we will get a stationary points. A stationary point may be maximum or minimum. For that, we will find further derivative, second order derivative, r, h and t, and one by one corresponding to stationary points, we will find the value of rst and test. Rt minus s square is greater than 0. Then see the sign of r. If r is less than maximum, r is greater than, then minimum, greater than 0, then minimum. And if rt minus s square is less than 0, then there will no maxima, no minima. Stationary points is not maxima or minima. That is a saddle point, because surface descends and ascends in different directions. Okay. And if rt minus s square is equal to 0, then case is doubtful and other technique should be used for deciding whether function is maximum or minimum at that point. Okay. So remember this working rule for solving questions. Okay. So now take the questions. Examine the maximum. Examine the function. Given function is x cube plus y cube minus 3axy, where is positive constant for maximum and minimum value. Just we will try here. So solution. Clear? So solution. Given function is what? F xy equals to x cube plus y cube minus 3a x and y. So this is function, given function. Okay. Just we will try to find the maximum or minimum value of the function, if exists or not. Okay. Here, for finding stationary points, for or we can write, we have what? What is our rule? Del f by del x, del f by del y finding, and then RST also. So just differentiate it. Del f by del x is equals to, with respect to x, partially differentiate 3x square minus 3y. Just see here, 3x square, this is 0, minus 3ay. Okay, and del f by del y equals to 3y square minus 3ax. Clear? Similarly, we require RST, so solve also R equals to del 2f by del x square. R means second order derivative. 6x with respect to x. 6x only. This is constant 0 for x. S del 2f upon del x del y. You can differentiate any of these two. So first y with respect to y and then x. So with respect to x, you can differentiate it with respect to x. So we will get minus 3a. And if we differentiate it with respect to y, then we can get 3 minus 3a also. And t del 2f by del y square, 2 time differentiation of this with respect to y, 6y. Clear? So these are the value of r as t. Okay? Now for maxima, and minima. For maxima and minima means necessary condition we will use for finding a stationary point. The stationary equations are, so we can write for maxima and minima del f by del x equals to 0, and for maxima and minima, this is the necessary condition. So del f by del x equal to 0, del f by del x equals to 0. By solving these two, we can get stationary points. So del f by del x is this. So implies 3x square minus 3ay is equals to 0, and second 3y square 3ax equals to 0. Now solving this two equation, solving these, equation, we get a stationary point. Points as follows. Just solve this and this. From here, we can see that for solving this, just in here 3 x square, we can write, you can do it also in rough one for solving. Okay, here 3 not 0, so x square equals to ay, x square equals to x square by a, y equals to this. From here y equals to x square by a, and from here y square equals to ax, y square equal to ax. So we can write, just solve it. Okay, y square equals to x square by a, or y equals to x square by a, and also here y square equals to ax. So see, for solving y square, x square by a square equals to x. So here we see that x power 4 equals to a power 3, a square and 3 x. So we can take common x cube minus a cube equals to 0. So implies x minus a, x square plus ax plus a square equals to 0. Just we can write like this. We can write like this. For solving here, solving this two, this and this. Factorization of this is x minus a, x square plus a square. This will give complex root. This will give complex root. So here just consider real root, x equals to 0 and a. X equal to 0 and a. The corresponding value of y, x equal to 0, x equal to 0, then y equal to also 0. X equal to a, y equals to a square by a. So here x equals to a, so y equals to this. This is y equals to. Okay, here y equals to x square by a. So a square by a means a. So implies corresponding to y equals to 0 and a. So points are what? A 0 0 and a 2 points. We get stationary points. Just solve it on the right hand side and write the stationary point. This is first point, this is second point. Stationary point at 0 0 and at a. Now corresponding to this point, just find the value of r, h and t. Okay, and by using that value we will try to find behavior of the stationary points. Behavior means whether this stationary point is maximum or minimum, whether this stationary point is maximum or minimum, maybe maximum, maybe minimum, may not be. Okay, so for that we can prepare, if there are 2 points or more than 2 points, then 2 points, then we can test one by one, or 3 4 points, then you can get you can make a table for finding value of RST. Okay, so here point 0 0 and a. So just denote this point by a and b. Okay, now at a, that means 0 0, we see that, just find RST, because by using the condition RT minus S square is greater than 0 and sign of R, we can decide whether maximum or minimum, and we can get also the maximum value and minimum value at that point by using the value of the function. Okay, so here at a 0 0 we see that r equals to 6x 6 into 0, because x equals to 0 0, s minus 3a t, here a is positive constant, suppose. Okay, t equals to 6 into 0 equals to 0. So implies RT minus h square, this is equals to 0 into 0, r into t, 0 into 0 minus h square 3a square equals to 9a square minus 3a, so h square minus 9a square is less than 0, negative. At 0 0, RT minus h square is equals to 0 into 0 minus this, we see that my sign is minus 9a square. A square is positive and this minus, that is negative. So RT minus h square is negative, implies RT minus h square is less than 0, which implies that at 0 0 there is no maximum and minimum. There is no maximum and minimum. There is at 0, 0 there is no maximum and minimum because RT minus square is less than 0 at 0, 0 at this point. Okay, at point A. Clear? There is no maximum and minimum. Okay. Testing is okay. Now, at the point A. Suppose this is A, this is A. Okay. Now, same process will follow for, you can also write there is no extreme value. Extreme value means either maximum value or minimum value are called, maximum value or minimum value are called extreme value. So there is no extreme value for the function. RT minus s square is less than 0 there. Okay. Now for second point A, point A, we see that R equals to what? 6 into A. X equal to A. S equals to minus 3A. T equals to 6A. And RT minus S square. RT minus S square. 6A into 6A minus 3A square. Because here minus 3A as it is, because there is no xy. So this is equals to what? 36A square minus 9A square equals to 27A square is greater than 0. Okay, 27A square is greater than 0. Clear? RT minus S square is greater than 0. Else, and R 6A greater than 0. A is positive quantity. Okay. So minimum value. Clear? This. So RT minus S square is greater than 0 and R is greater than 0. Implies at AA, what? The function fxy attains maximum value, minimum value. Here R is greater than 0, minimum. Minimum value. Clear? This is greater than 0 and this is greater than 0. So at BAA, this point, at this point, the function fxy attains minimum value and minimum value is f minimum at AA. How can you find? Just put the value AA in this. So AQ plus AQ minus 3A into A. That is what? Minus 3 AQ, 2 AQ equals to minus AQ. So this is answer, minus AQ. Minus AQ is the minimum value of the function. You can say if this condition is satisfied, this is a point of minimum for the function. Point of minimum for the function. So at this point minimum. So there are two stationary points, 0, 0 and A. 0, 0 and A. At 0, 0, no maximum, no minimum. And at no maximum, no minimum means what? Saddle point, either maximum or minimum. Ascends in one direction and descends in other directions of that point. So, no maximum minimum. At the point B, AA is positive constant, so AA, at AA function is minimum. And minimum value is minus AQ. Minimum value can be found by putting the value of the point in the given function. Okay, so this is the process for finding maximum minimum value of function of two variables. Here, main thing is what? Just find RST, first order derivative, first order derivative equals to 0. Then the necessary condition gives stationary points, find stationary points, solving that two equation, and for corresponding to each stationary points, we are testing for whether this stationary point is maximum point or minimum point. Maybe maximum, maybe minimum, may not be. So RST find also second order derivatives, and then at each point just try to identify for maximum minimum for finding RST at that point. If greater than 0 and R greater than 0, minimum. R less than 0, greater than 0, R less than 0, maximum. If this less than 0, RT minus S square less than 0, then no maximum nor minimum. And if this is equal 0, then further method is required for testing, because no doubtful case in that case. Okay. Take second questions. Solution. That is, discuss the maximum minima of fxy equals to x cube y square 1 minus x minus y. Here, given fxy equals to x cube y square 1 minus x minus y. 1 minus x minus y. Fxy equals to, okay. So just we have to discuss the maximum minimum for this function. Okay. So we know our procedure is very simple. What? We have fx. We can write fx del f by del x. That is what? Del f upon del x. Just differentiate it. Clear? We multiply and differentiate it with respect to x. So here 3, just multiply it, x cube y square. So 3 x square y square first term minus second term x or 4. So 4 x cube y square minus y power 3 y square x cube. So this is first. Clear? Similarly, just our process is what? Finding fx, fy. Fy means what? Del f upon del y with respect to y. So here just 2y x cube minus, again with respect to y, so 2y x cube 2y x power 4 minus 3y square x cube. Okay. Also r equals to, again differentiate it, fxx means what? Fxx is what? With respect to x, 6x y square minus 12x square y square minus 9x square y square. 9x square y square. Okay. R equals to here 3 with respect to x, just see 3 x square y cube, x square y cube minus 4x cube y minus 4x cube y square minus 3x square y cube, 2 minus 2 minus 3, 2 minus 2 minus 3. Okay, just after at the time of differentiation, just see carefully. Okay, here what? Our differentiation of x, 6xy square minus 12x square y square with respect to x, 6xy cube, 6xy, r equals to. Similarly, s equals to what? F x y. You can differentiate this with respect to x. First y with respect and then x. So here with respect to x, this 6x square y minus with respect to x 8yx cube with respect to x 9y square x square minus 8xy minus 8x cube y. Okay, this t, because our main thing is what? Finding r as t at a stationary point. A stationary point will give by this equal to 0, this equal to 0. Okay, t equals to f y again with respect to y, differentiate it. So y, so 2x cube 1 with respect to y minus 2 x power 4 minus 6 y x cube, 2x cube minus 2x power 4 minus 6x square y, 6 here with respect to y, so y cube 3y square x cube is there, so 6y with respect to y, 6y x cube, there will be 6y x cube. Okay, clear? These are the derivatives, first order, second order. Okay, now for maxima and minima, fx equals to 0 and fy equals to 0. Both should be equals to 0. So solving it, 3 fxy equals to 0, this is equals to 0. So here common, take common, square. So 3x square y square can be taken common, x square y square. X square y square common minus 3. Clear? So x square y square common, then 3 minus 4x minus 3y equals to 0, first equation, and second this yx cube common, yx cube common, yx cube common. So 2 minus 2 minus 2x minus 3 y equals to 0. Just we get like this. This equals to 0 and this equals to 0. Okay, this is not 0, this is not 0, so we we get two equation, implies what here? See, 3 minus 4x minus 3y equals to 0, and here 2 minus 2x minus 3y equals to 0. We can solve it. On solving, we can get the value what? 0, 0, 1 by 2, 1 by 3. X equals to 0 and 1 by 2. X equals to 0 and 1 by 2. Okay. 0, 1 by 2. 0, 1 by 2 and 0, 1 by 3. So, this implies corresponding value of y equals to 0, 1 by 3. So the stationary points. The stationary points are A 0, 0 and B 1 by 2, 1 by 3. These two are stationary points. Okay? Because these two equations are solved. As a linear equation, you can solve x equal to 0, y x equal to 1 by 2, y equal to 0, corresponding value of y is this. So, stationary points are this. Now, we will check one by one at this point the value of RST. Okay. At B 0, 0, not 0, 0, 1 by 2 and 1 by 3. Okay. At this point first, 1 by 2, 1 by 3. We see that R equals to means what? This. R equals to this. Clear? So, 1 by 1, we can see that value of R is RT minus S square. You can direct solve RT minus S square. Okay. So, R into T means this into this. Okay, this into this minus this square. Clear? So here we see that here x cube can be taken common, here x can be taken common, so x to the power 4 taken common, and here y, no, there y, so here y square can be taken common, because these two are multiplied, so this can be taken common, and in this side here multiplication factor we can write like this: 1 minus 2x minus y, 12, 1 minus 2x minus y, 1 minus x minus 3y. 1 minus x minus 3y minus 6 minus 8x minus 9y square. 6x minus 8y minus 9y. 8x minus 9y square. Because we are taking common x to the power 4y square, x square y, x square y, x square y can be taken common. So 6 minus 8x minus 9y square is inside. This is the value of rt minus s square. After writing this, just put the value. Put the value. Clear? So for putting the value, 1 by x to the power 4 means 1 by 16 into y square 1 by 9, and just you can put the value here. 1 minus 2 into 1 by 2 minus y 1 by 3, 1 minus 1 by 2, 3 into 1 by 3 minus 6, 8 into 1 by 2 minus 9 into 1 by 3 square. This is equals to 1 by 14, equals to 1 upon 14, implies rt minus s square. Just our target is what? At this point 1 by 2, 1 by 3, x equal to 1 by 2, y equal to 1 by 3, put here and here and also here, and find rt minus s square equals to, just you can get like this value, this is greater than 0. So rt minus s square is greater than 0, and also r equals to, just see here, r equals to what? Here 6 can be taken common, and xy square means x means 1 by 2, y square means 1 by 9, minus 2 x square y square, minus 2 into 1 by 4 1 by 9, and minus 1 by 2 1 by 27, 1 by 2 1 by 27, this. Okay, here y cube 1 by 23 is cube 1 by 2, so this is equals to minus 1 by 9, less than 0. R is equals to minus 1 by 9 is less than 0. So here we see that rt minus s square is greater than 0 and r is less than 0, that is maximum, 1 by maximum point. Okay, so we can give the decision like since rt minus s square is equals to is greater than 0 and r is less than 0, at b 1 by 2 1 by 3, therefore b is a point of maxima and maximum value and maximum value and maximum value is, maximum value can be find 1 by 2 1 by 3 putting in the equation. F maximum at 1 by 2 1 by 3 equals to 1 by 2 cube 1 by 3 square this is equals to what? 1 by 432. 1 by 432. This is the value. Okay. 1 by 432. Clear? And second point. Now, our second point is what? 0, 0 point. So here, at 0, 0, at 0, 0, second point, B, at point B, at point B 0, 0. So here xy is present everywhere, so RT minus S square is equals to 0. RT minus S square equals to 0. At 0, 0, RT minus S square, so you can see that this is equals to 0, 0. And in this case, how can we decide? Because here 0, 0, that means which implies that the further investigation is required. In this type of situation, just we can think in other way, accept this method. Okay, because at 0, 0, whether, because RT minus S square is equal to 0, so case is doubtful. So here we can consider geometrically, because geometrically means by considering points nearer to 0, 0 in the domain of the function, how value of function vary. How value of function vary. So here, just we see that for this function, domain is complete plane, xy plane. So, in the xy plane, we can take any point for consideration as a domain of this function. So, just consider on the line this y equals to x. And if we take nearer points to this, here, 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 we can take point. So just nearer point we can take. And if nearer to 0, 0, there are points where value of the function is, value of the function in the upper side, value of the z is one time greater than f00, one time less than f00, then there will be no extreme orbit. For discussion here, at A00, consider on the line y equals to x, that is fxy equals to what? X cube y square 1 minus x, that is x power. Here in place of y you can also write x square, so x power 5 1 minus 2x. So this is the value of function. Clear? This is the value of function. Now at x equals to 0.1 fx, fx fxy fxy is positive and at x equals to minus 0.1, nearer value, 0, 0, nearer value. X equal to 0.1 means 0.1, here 0.1, 0.1. So x equal to 0.1, x equal to minus 0.1, this side and this side. fxy is negative. Clear? At point 1 positive and negative for point minus 1. That means what? In the neighborhood of 0, 0, that is, you can write, that is in the hood of 0, 0, there are points where fxy, there are points fxy is positive. So fxy is greater than f 0, 0. And also there are points where fxy is less than f0, 0. f0, 0 means 0. So less 0, negative, greater than 0. Positive. Okay, that means neither maximum nor minimum. So the f0, 0 is not an extreme value. Extreme value means maximum minimum, not an extreme value. At 0. So stationary points, there are two stationary points, 0, 0 and 1 by 2, 1 by 3, 1 by 2, 1 by 3 at 1 by 2, 1 by 3. The function is maximum and maximum value is 1 upon 432, and at 0, 0, 0, 0 is not an extreme value. Okay, stationary points may be maximum or minimum or may not be. So here, not an extreme value, not an maximum or minimum value. Okay. Now take second question. Next question. Here, whenever we are given a function which is a function of more than two variable, maybe three variable, if there are some condition in that three variables, because in general function of two variable means what? There are two independent variables. Okay, if independent variables, there are independent variables, three independent variables, and they are separately not purely independent. That is, suppose a function of three variables and three variables are also connected by some relation. In that case, we can generally we are trying to write the function as a function of two independent variables. Suppose sometimes there are function x, y, z, function of three variables, and these three variables, this function of three variables, and these three variables are also connected by some relation. Then if maybe these three variables are connected by one relation, two relation, three relation, if these three variables are connected by a single relation, and from this relation we can write the value of one variable in terms of other two variable, then by putting that value of that variable in this, we can convert it in a function of two variables. So just first case, whenever we are having a function in three variables, just try to convert it in function of two variables, and then try to identify maximum minimum values. Okay, generally this is the first step. This relation, if this relation is very simple relation, so by this relation we can convert it. Now after finding two value, then we can get third value from this relation. So that will be the stationary points. So here one questions, just very important questions. See it. We have to find the extreme value of cos A, cos B, cos C, where A, B, C are internal angles of a triangle. Clear? Maybe three variable angles are variables as x, y, z. You can write also cos A, cos B, cos C, or cos x, cos y, cos z. This is our function. Okay. Here let our function is u equals to cos A, cos B, cos C. That is, you can also write x, y, z cos in place of, where A plus B plus C equals to pi. In triangle, because internal angles of a triangle. ABC is a triangle. Sum of angles is equals to 180. So here two relations are there. This is given function, this is one relation. Here ABC are the variables, they are connected. Clear? They are connected by a relation. They are connected by a relation A plus B plus C equals to pi. So this is equation 1, equation 2. Clear? Here function of three variable, so we are trying to convert it in two variable. By using this relation we can write implies u equals to cos A, cos B, cos of C means pi minus A plus B. Cos pi minus this. That means here we can write minus cos of A, cos of B, cos of A plus B. Cos pi minus theta equals to minus cos theta. So this is our what? U. So u is a function of A and B. We can write. Clear? So this can be written as a function of AB. What is u equals function of AB? Function of AB. Now function of two variable is this. No. What? Fx, Fy. We have to find. Now we have del f upon del A. Differentiate it with respect to A. With respect to A, B is constant. So minus. Here we can see that cos B is constant. So cos B. Now minus sign of cos B. Here A cos A, its differentiation minus sin A, and cos A plus B, and its derivative minus with respect to differentiation with respect to A, B is constant. So here cos means minus sin A plus B, and again A plus B differentiated 1 into cos of A. So here we see that what this is equals to minus common. So sin A cos B, cos A sin B. So sin A 2A plus B. We can write sin 2A plus B. So minus minus plus cos A sin 2A plus B, cos A. Clear? So this is del F by del A. Similarly you can find del F by del B equals to cos A sin 2A plus B. So here B cos A cos B, sorry, this is cos B. Now cos A sin A plus 2B. Similarly you can write as a similar process. You can find value cos A sin A plus 2B. Okay. Clear? This. Differentiate it with respect to A and B partial, then you can get cos B sin A 2A plus B, here cos A sin A plus 2B. So just write now here cos B sin 2A plus B after differentiation. And this for maximum minima, for maxima and minima, del f by del a, del f by del b. This is equal to 0, this is equal to 0, both are 0. Implies a equal b equal pi by 3. Just I am writing here directly. Where this is equal to 0, this is equal to 0, you can solve it. How? By solving, we can see that cos b sin 2a plus b, cos a sin a plus 2b. Just solve it. This is equal to 0, this is equal to 0, implies a equal to b equal to pi by 3. How? Here, see, since cos b sin 2a plus b equals to 0, okay, and also cos a sin a plus 2b equals to 0. That means from here either cos b equal to 0 or cos a equal to 0. In case of 0 0, a equal b, either this equals 0 or this equals 0. 2a plus b equals 0 or a plus 2b equals 0. In this case, for 0 0, it can be satisfied. Okay, so for solving these two equation, we can see that when cos a cos b 0 0, then these two quantity are equal to 0. So in this case here, see here, its solution implies cos a equals 0 equal cos b sin 2a plus b equal 0 equal sin a plus 2b. Means either this equals 0 or this equals 0, this equals 0 or this equals 0, this equals 0, this equals 0, you can equate it. A equals 0, b equals 0. If a equals 0, b equals 0, there will be no triangle. So it is not considerable. Now, this equals 0, this equals 0. This equals 0 and this equals 0, you can solve it. How? Here, sin a plus b equals 0. Sin 2a plus b equals 0. Sin a plus b equals 0. So sin a cos a plus b plus cos a sin a plus b equals 0. So from here we can see that on transferring right hand side, this will minus sign. So cos is taken here. So tan a equals to minus tan a plus b. Okay. Similarly from here, a plus b plus b. In that case, also we can write similarly. Also, from this relation, a plus b plus b, tan b equals to minus tan a plus b. Now from these two, tan a equal tan b. From these two, tan a equal tan. 10 equal 10b equal minus 10 a plus b. From here 10a equal 10b, that means a equal b. A equal b also must satisfy it. So 10a equals to 10 to a. So we can write after this line 10 a equal minus 10 to a. From here a equal b, so 10a equal 10a plus a, 10 to a. So this is equals to minus 10 to a means 10 to a formula what? 2 10s by 1 minus 10 square is 2 10a by 1 minus 10 square a, 10 to a means. Okay, so here we can write 10a. So by solving this we can get the relation. How? Ten a minus 10 qa equals to minus 2 10a. So here we see that 3 10a minus 10 qa equals to 0. So here 10a 3 minus 10 square a equals 0. So implies 10a equals 0 and 3 minus 10 square a equals 0. Implies 10a equals to 1 by root 3. Implies a equals to 5 by 3. Okay, 10a equals to root 3. 10a equals to not root 1 by root 3, root 3. Sorry. 10 equals to root 3. Here 10 equal to 0, a equal to 0, not considerable. Here 10 square a equal to 3, so 10a equals to root 3, a equals to pi by 3. Clear? Now a equal to pi by 3 equals to b. And also by using this relation, a pi by 3, b pi by 3, c equals to also pi by 3. Okay, so here f is function of two variable and a stationary point is pi by 3 pi by 3. A stationary points is pi by 3, that is pi by 3 pi by 3, that is this. Now just we will find RST. Okay, now we can get, let's do it, r equals to del 2 f upon del a square, del 2 f upon del a square. Just differentiate it, first function, second function, differentiation with respect to a of this. So r equals to, just write r equals to 2 cos b cos 2a plus b. Here constant, so 2 cos b cos 2a plus b, and s equals to del 2 f upon del a del b. We can differentiate it with respect to a, and then just you have to solve it. Okay, so cos 2a plus 2b, you can set out after differentiation function of product of two function, and then using cos a plus b formula, so it is cos 2a plus 2b, cos 2a plus 2b. Just do it, differentiate and set out by cos a plus b formula, and t equals to del 2f by del b square, del 2f by del b square. This is equals to what? This is equals to, with respect to b is a constant, so cos, similarly to cos a plus 2b. Okay, so these are the value of RST, and its value at pi by 3 we can find just putting a equal to b equal to pi by 3. So get its value, cos a plus 2b, 2 cos a plus 2b. So r minus 1 s minus of t minus 1. So here at a equals to b equals to pi by 3, r equals to pi by 3 cos 61 by 2. R equals to minus 1, S equals to minus half, T equals to minus 1. Just you can calculate. R equals to minus 1, here 1 cancel, a means pi by 3, so 2 pi by 3 plus pi by 3, 3 pi by 3 cos pi minus 1, so minus 1. Also this is minus 1, this is minus half. So minus 1 minus half minus 1. RT minus S square equal to RT minus S square equals to minus 1 into minus 1 into minus 1 by 2 or square. So 1 minus 1 by 4 equals to 3 by 4 greater than 0, implies RT minus S square is greater than 0 and R equals to minus 1 is less than 0. RT minus S square is greater than 0, R equal to minus 1 is less than 0, implies what? Implies FAB is maximum. Implies FAB is maximum at A equal B equal pi by 3. FAB is maximum. U is maximum. Cos A cos B C is maximum. Also from 2 A plus B plus C equals to pi implies pi by 3 plus pi by 3 plus C equals to pi implies C equals to pi minus 2 pi by 3 pi by 3. Okay, C equals to also pi by 3. Pi minus 2 pi by 3 means pi by 3. Hence, cos A, cos B, cos C is maximum when A equal, B equal, C equal pi by 3. And maximum value equals to cos pi by 3, cos pi by 3, cos pi by 3 equals to 1 by 2, 1 by 2, 1 by 2, 1 by 8. This is maximum value. Okay, 1 by 8, maximum value 1 by 8. Okay, so this is the process for finding maximum value or minimum value and deciding whether value is maximum or minimum. Okay, function of 3 variable, by a relation we can convert it into function of 2 variable, and then we can use rt minus h square greater than 0 and r less than or greater than, you can decide. So this is maximum value 1 by 8. Okay. Now I will give some questions. For your practice. Okay, so do some of the questions for your practice. Here maximum minimum of function of 2 variable is very important for this unit. Okay, so there is another method. I will discuss that in the next class, but now by using this technique rt minus h square and r value of r, you can determine the value of function as a maximum or minima using the condition. Okay, so here I will give some questions for your practice, so do it. So these are the questions. 5-6 questions are this, and you have to complete this questions by using the method. Just if there are function of 3 variables and there is given another relation, then you can convert the main function as a function of 2 variable by using this connected relation, and then you can proceed just like cos A cos B cos C. As a function of 2 variable, you can solve it for del f by del f, one variable, del f by del second variable, and put it 0, and then you can solve it for stationary values. After getting a stationary value, at each stationary value, just find RST and check RT minus TC square is greater than 0 and see the sign of R. If R is less than 0, RT minus TC square is greater than 0 and R is less than 0, maximum. R is greater than 0, minimum. If RT minus TC square is less than 0, then there is no maximum, no minimum. That is certain point. And if RT minus TC square equal to 0, you cannot decide by this method. So check by using another method, another geometrical method, and etc. So first of all, find stationary points by putting del f by del x equal to 0, del f by del y equal to 0 in case of function of two variables. Okay, then find second order derivative RST and find values corresponding to all the stationary points and test by using that working rule for finding derivatives, finding maximum minimum. Okay, so these questions are very, very important. Solve it. Okay, and then the next class I will discuss about Lagrange's multiplier methods for finding maximum and minimum value. In that case, we can also find stationary points, and in some of the questions we will discuss about whether maximum or minimum. Okay, so do these questions. These are the practice questions for you. Okay.